The upcoming presentation, titled Automatic Detection, Geolocation of Persons on UAV Images to Assist in Search and Rescue Operation, will delve into the life-saving potential of deep learning models in search and rescue missions, highlighting the innovative use of drones and computer vision for locating individuals in dire situations in the wilderness. Marina Ivasic-Kos is a Dean at Faculty of Informatics and Digital Technologies and Center for Artificial Intelligence at University of Rijeka, and she will reveal the cutting-edge advancements and the intense challenges encountered in these high-stakes, real-world scenarios. Marina, please welcome to the stage. Nice to see you again.
Thank you. Thank you. Hello, everybody. So I'm very pleased to be here and to present you our work. So just to check how this works. Okay. So the title is, as was introduced, and I will show you some research related to drone imagery that was used in search and rescue missions. So I will start with, well, some introduction, and then I will show you the pipeline of building the data set to train the model and to test it on the environment that is very similar to that of rescue missions. And then also I will show you some more experience related to geolocation of persons that was detected at some place in the, woods or in some nature. And I will finish with our future work. So just to start with, about our motivation. You know that we people very enjoy spending our time in nature, in wildness. And usually we are not very well prepared for that missions. We like skiing, hiking, climbing, or walking through the woods. But sometimes also some injuries or some accident happens. It is not very often, but really happens, and it's very important for our life. Sometimes it is at stake of our life, and the most important thing is that survival comes very fast, that they are efficient, and that we have time for rescue. So the mission, the search and rescue mission, starts when some accident happens, and the idea is to take all the resources that is available and to get to the location as fast as possible and find the person. So usually they are using, besides the people, also the searching dogs, vehicles, helicopters, which are very expensive, and in the recent times, mostly drones. Here is some scenery that looks like, and it's some examples of missions of SAR mission, Safe and Rescue Mission. And the images are took with drones. So what you can detect, there are some people here, but it's very hard to detect them, even for us, because they are here in the shadow, and also they are very small, or sometimes their poses are, not, I can say not normal poses, because they have some broken legs or broken arms. And the fact is, if we are taking drones, and if we are flying from very height, about 40 or 50 meters, then we have some sceneries like this, that one below, and it's very difficult to even now detect the people, but also here on that hill, on the slope, there are some people that will fall here, and it's very difficult even for us to detect them. Well, we are not trained, but even for people. So the main challenges of all SAR mission is that usually they are on some, they happen on some unfavorable or bad weather with, snow, rain, or maybe fog. And also, many times, the rescue forces, they have very limited data about the missing person. Maybe just the name or the age, and not more data about the clothes, the direction, or the aim of, I don't know, handling around the woods. So it's very difficult to locate or even the area that should be searched. Also, usually the terrain is where it's not easy accessible, and it's even for rescue forces, it's not easy to come to that location. And above all that, they have to process in real time and according to, well, their equipment and their ability. So now, usually, well, the aim of SARS mission, of course, is to find the person in shortest possible time and if possible, in best health position. And with human resources and material as less as possible, and at the safest way for even the rescue forces. So the time is key factor. And with spending or with passing of time, the thing is that the area, the search area, is increasing, and also the chances of finding the injured person decreases as well. So we have to perform as fast as possible, and we have to take all the equipment that we can use. So here is again a spot to spots in a slope with two persons. They are very, very hard to detect, and here they are just zoomed to that you can see how that looks like. That was not a real injured person, that was just the people we used to build our data set. And also now the drones are, are used in many different domains for surveillance, even in cities, in the woods, in some agriculture, and there are some drones which are really sophisticated and can be used even in SARS mission. Usually they are something like this one. I just pick 3 of them, and usually they are equipped and with camera, which is, well, the baseline, but also with some LiDAR, laser, stereo cameras, infrared cameras with automatic zoom, so they can really help the mission. And also, yes, they are helpful in location of the person and also in increasing the survival time. In decreasing the time of the mission. But of course, they are, well, very expensive, usually about 30,000 euros or more. And we are in Croatia, and our team usually has only one or neither one of those sophisticated drones, but they have some well, not custom-made, but that commercial drones that are affordable and can be used. So our idea was to help our rescue teams and our rescue missions and to somehow equip the, I can say, regular drones with AI models to help them in their mission. So in the usually, that is the real picture from the mission, and usually they are using drones during the mission, and at that time they are looking at the monitor and try to detect the person. But usually, at that time, it's a very, well, it's difficult to detect some spot in the image with some sign of life, because you have to monitor and inspect all the area of the image. And usually, if the drone is flying on the big location, on the very high then the pixels containing a person are just few. So most of the time, if the person is not find during the mission, because even the battery is limited to 30 or 20 minutes. So they change the batteries, but also then if they have all that materials, usually they inspect the materials after the mission. So it's, it's a very important job, but at the same time is very tiring, and nobody can be concentrated for the long time. What we want to do and how we want to help them, we want to try to train and to build a neural network model for person detection, which can be used in online mission during the flight, but as well in offline when they are inspecting their materials. So first, we inspect and we analyze all the data sets that are open and are captured with drones. And those are the most popular. But the problem is that all of these data sets don't have the images and scenes that are related to the wilderness, the woods, and the scenery where usually we find injured or missed persons. So we can use it in some part of the building our model, but we can't train the model on that images. Also, as I shown you before, we have a person in some irregular poses because of the injury, because of the fall. So usually they are not standing or usually not just walking. So even for that pose detection, we had to build the data set. Then the second phase was to detect analyze all possible detectors. We were interested just in that real-time object detector, and for recent years, YOLO and all these models in YOLO family are the best according to performance and inference time. So we just checked the standard models, and they are on that is the reported performance on the COCO data set. They are trained on COCO data set and on validation or data set that are the results that YOLO reports. That are the latest model from 2022 and 2023. And you see the performance is rather similar. So we found that we have to build, that is the pipeline of our research. We found that we have to build a data set. We add some augmentation, because usually the data, the time when the rescue mission is performing is with rain, with snow, with fog, and so we augmented our data set, and also then we trained the model. So that is some images of a data set. We used models that were the people from 7 to 55 years of age, and we put them on some positions to simulate the injured people. We used, I said, custom, or no, not custom, but a regular commercial drone. It's a Phantom 5. And after that, after taking all these pictures and images, we did some data augmentation. And after that, we manually annotate all the persons of the images. So that's a little bit of the statistics of our model. It's about 2,000 images, 6.5 person objects, and probably the very important part is the size of the object. We have many very small objects, which is less than 32 square. The most of them are medium, and very few, or about 40 and 60 large objects. So we used, transfer learning. First of all, we tried just a regular or base model. It was YOLO version 5, trained on the COCO on our data set. But as you can see, the performance is very, very poor, according 23 or of average precision, or in case of if we want to be more precise, it's about 40.2%. So we were not satisfied with that because the decrease from the original model tested on the test data set is, is very big. The drop is very big. So we trained it on and retrained it on our data set. And the performance is that is, we arrived on 95%. So we were satisfied with that results. Also, we tried different methodologies of transfer learning, and we reported all of them. But we haven't achieved better results than 95 or 96% of average precision. Also, we tried, and even other models, just to be sure if we have picked the right one. And you can see the comparison among YOLO V2, V4, and Cascade, RetinaNet, and other models. And here is the YOLO model. It is that blue circle, which is the best in a case with the highest performance, the highest precision, and rather the highest and second in the recall. So after that, we tried to build a system that can be used in rescue forces. And now they acquire the data. We pick all the data from the mission, as well as the position of the drone, the GPS position, the digital evaluation of the map where the drone were flown, and then we can perform the person detection. But also because when in offline, you just want to, when you detect the person, in that case, you don't know the exact geolocation of the person, where the person is, because you're in the 2D and the person is somewhere out in the real scene. And also, usually the drone is not above the person, but it's from some distance that the person is captured. So in that case, we have tried different models, and in this one, we try to use a raycast to detect the position of the person. So basically, what have we done? That is in offline detection. We know the detection or the position of the detected person. We also know the dam of the terrain over which the drone was flown. And then we simply use the intersection of the raycast and the position of the person to calculate the position of the person where the person can be. And that is the few images which are 800 times zoomed. The person is somewhere there, but you can see the exact detection of the person. And also here are some just examples of the detection and geolocation of the persons. Because the person are so tiny on the image, we use zoom just to present you how that looks like. So first we detected the person, and then in offline we have the dam map and the map of the terrain, and we can calculate the distance. We have the error is about 10 meters, and here is the red dot is exact and ground truth of the position of the person, and the blue one or magenta is the one that we predict that the person is, or calculated that the person is. I will show you some more images. Usually those Those dots here are presenting the flights of the drones, because usually the drone is flying over the field many times, and not in all times probably the groups cannot detect in each time even the person exists there. So we also had many images of the same terrain, and so I just demonstrated how that looks like. And so the procedure is the same. If we detect the person, we know the exact position, we know the coordinates of the drone, we know how the camera was positioned, the field of the camera, and all the data. And also we can calculate and predict the position of the person. Also, we tried with different methods, just using maths and some distance calculations. But also, we tried to detect even the direction and speed of movement of person. And to do so, those three images. There are three stages. One is when when the drone is standing and the person is moving, or the drone is standing and person standing. And this one is that the person is moving, the drone is stationary. And the other one, the third, is the drone is moving, that is that blue line, and the person is moving also. The orange line is the original one, and the yellow is what we predicted. So you know that we have problems even with detection, and then also we somehow that detection box, we use just a dot to approximate that distance, and then we use some calculations to calculate the position, the geolocation, and also the direction and the speed. And that is the field where we have to investigate even more. We just started. And also for future work, we made some model that is used already in our rescue troops, but also we want to use infrared cameras and to build the model to be able to detect a person even when it's very hard to detect everybody and it's really bad weather. My colleagues in the teams are the colleagues from my faculty, but also the members from other institutions and we have some industry partners. So that is a hard work that we have done, and I'm thankful them as well. That is all for my presentation. So if you have a question, I welcome it.
Yes. There's one question here to begin with. Wait for a mic. It's coming.
Okay, thank you. Fascinating talk. I have several questions, actually. But you said that this approach works in adverse weather conditions, but does this work at night?
No, for now not. Because of that, we want to use the infrared cameras. And we tried, but the problem was it was not so easy task. We have to rebuild the model because it was not as we expected. Infrared was work very well in spring and in autumn, but very bad in in winter and in summer, because all the experiments were on the above of the mountain with so many rocks, and we had just everything white. So we had very, very big problem with that, and we have to try the model.
Okay, and the second one, so YOLO is notoriously bad with detecting small objects, so how do you overcome that?
Well, we tried the model, and I haven't expressed really your question. YOLO has...
YOLO, yeah.
Yes, yes, yes. First version of YOLO, yes, they had really big problems with small object. But you see, we had some YOLO version 5, which is augmented with some backbone, and also 7 and 8, and there is, well, a significant increase in precision. So...
And just a quick one. Did you use generated data or try to maybe?
Yes. The first part of the data was real data with just person used to simulate the positions. Also the augmented data, but that was everything was simulated. But now, yes, we are using simulated data not only for woods and mountains, but also for sea, because also there are a great need to, well, to help the person that are drawn and that are somewhere in the sea, and we can't put the person simulating that they are somewhere in the middle of sea drowning or something.
I have a question here.
Yeah, thank you for the talk. It's a good example for AI being used for the goodness, you know. My question is, how do you decide where the drone goes? What kind of program? How do you determine the route? How do you determine the behavior of the drone?
For one of my PhD students is a member of rescue forces. So for us, we took all the experience what they have, and already they know even where to go, where is the use location that the people go. They also know that probably if we are going somewhere and we are working or a person that use the right hand, that probably the right leg is the strongest one, and so because of that we probably turn on some, I don't know, right direction or something. So now they already know, well, the behavior, and well, there is a, well, I can say a big theory about, because that is the most important thing is they had to know who is the missing person, because according to that they can, well, somehow realize according to statistics, what are the places that the person can be, how is performing, how fast is, I don't know, walking and whatever. So that information is very important for them.
Okay, so because I'm thinking about reinforcement learning in how you know, image detection or computer vision coupled with reinforcement learning could basically, I don't know, because you said you see a person but it's only 2 pixels, so you're not sure. So if you can decide, okay, there's an anomaly, let's put it like that, or there's a percentage of, I don't know, 20% this might be a person, so we can guide through reinforcement learning, say, hey, take a look a little bit closer towards there, and you can increase your confidence level and say, okay, that really is the person. Have you think about this direction as well?
Yes, it's a great point, yes. And also, because of that, because of our knowledge about the terrain, that is very important, we use them, because also it's usually, well, I learned a lot from rescue forces, but also from the terrain, you can know that if there is some path or something, probably somebody will follow that, or probably will go, I don't know, in the top of the mountain because wants to be searched by a helicopter or something. So yes, it's very, well, our research is towering to using the reinforcement learning to, well, to somehow, well, strengthen the direction of the, well, even the forces, and to take everything what we know into account.
Thank you.
So that's all visual recognition. So what, I mean, how do you differ that this is a person, not that somebody discarded clothes or something, so they can be laying around? There's a lot of litter in this region.
No, we can't do that, because we just want
you cannot train it to recognize the body shape.
Yes, we can do that, but for now we are not so specialized in that. We just want to, if there is some clothes or if there is some, I don't know, bag or something, for now we will detect that and probably send the forces to check the position. And probably, because even now they are doing that in that way. But yes, we are trying to detect the poses of the person to be sure that, yes, that is the person and not some...
Not some garbage,
Yes.
for example, which can happen. Any other, because we are... No, we have to... We have to end.
Okay.
Thank you, and this is a certificate for you.
Okay.
For your attendance of DSC.
Thank you for
Thank you.
listening.